Okay, so on the second part of section 8.1, I want to talk about parabola. Parabola is a curve, and this curve we already learned in college algebra. You remember about the standard form y equal to x squared plus bx plus c. Anyone remember that formula? That is parabola, right? And we already learned it in college algebra. And we know that the leading coefficient, the a value, is important. It tells you parabola is opening up or opening down, right? If a is positive, we know the parabola is opening up, and if a is negative, it's opening down. But in this pre-calculus, we want to talk more about parabola. We're gonna go into the sideways parabola. The one is gonna be open to the right, and the one is opening to the left. So there are totally four different forms of parabola. Okay, so it depends on the a value. It depends on is the x value square is the one that's square, or depends on the y value is the one that's square. So it have four different form of parabola. But before going to the general formula of each form, I just want to talk about the standard one first, the one that you already learned in college algebra, and how we're going to convert those standard one, the basic one, to the one we're going to be learning in pre-calculus. Okay, so let's take a look at this one. Everybody know that this one is a parabola. Y equal to let's make up something, for example, like y equal to 4x squared, right? That is parabola, right? And we know this parabola with a is positive, so we know that this parabola is opening up, right? It's opening up because a is positive. And we also know that this parabola has vertex at 0, 0 at the origin, right? And another parabola, y equal to 2x squared minus 4x plus 5. Okay, this parabola is opening up also. Okay, and we don't know the vertex of this parabola, but we can find the vertex easily by using the vertex formula, negative b over 2a. You plug it in, you can find the y component of the vertex easily. Okay, so with these two parabola we already learned in college algebra, we're gonna try to derive the general formula, okay, for the parabola which the symmetric axis is the y-axis. Okay, so this parabola, let's start with the parabola on the left hand side over here. So this parabola I can manipulate a little bit more. I can write it like this. I can write it equal to 4 times 1 x squared, right? 4 times 1 x squared, right? And for this one, I can use the concept called completing the square, the one we already learned in college algebra also. So I can write like this. I can write I can factor 2 over here, so 2x squared minus 2x, okay, plus 5. right? I can write like that. Then I can add or subtract a number 1. Okay, why I have to do that? Because if I add or subtract, I can get a perfect square. Look at this, plus 5. Okay, so I'm gonna distribute the mean, so I'm gonna have 2 times x squared minus 2x plus 1, right? Distribute number 2 into this, so give you negative 2 plus 5. And this one is a perfect square, so I may have 2x minus 1 square, right? And negative 2 plus 5 give you positive 3. Right? And over here, I'm going to subtract both sides by 3, so I'm going to have y minus 3 equal 2x minus 1 square. Right? Everybody agree with me, right? Over here. Alright, now get back to this. Back to this one. So we know that over here is 4, it means it's opening up. Okay. The value number 1 right here, okay, I can give it a variable, and okay, I'm gonna name it variable p, representing a value 1 right over here. Okay, so in this one I can write, okay, I'm just name number 1 over here with variable p, so my equation becomes y equal to 4p x squared, right? 4p x squared. Okay. Let me see. Hold on. I think that. Okay, hold on. Not yet. All right. So I think we're gonna delete this too. So I'm gonna derive both sides by 4. So I'm gonna have 1 over 4 y equal to x squared. Okay. All right. And over here, I'm gonna divide it by 2. So I'm gonna have 1 over 2 y minus 3 equal x minus 1 square. Okay. All right. So now get back to this one. So this one I can rewrite as x squared equal to 1 over 4 y, right? And I can also rewrite it as x squared equal to 4 times 1 over 16y, right? Right, because 4 divided by 16, it gives you 1 over 4. Okay, now I'm gonna give 1 over 16 a variable. I'm gonna call the variable p. So my equation, okay, so I'm gonna let p equal to 1 over 16. Okay, then my equation will become x squared equal to 4py. Okay, and over here, I'm gonna rewrite it, so x minus 1 square equal to 1 over 2 y minus 3. Okay, and this one I can also write it as 4 times 1 over 8 y minus 3, right? Because 4 divided by 8 gives you 1 over 2. Okay. All right. Now I'm gonna give 1 over 8 a variable p also. So let p equal 1 over 8. Okay. Let's p equal to 1 over 8. Then my equation become what? My equation become x minus 1 square equal to 4p y minus 3. Okay, everybody's following me. All right. So everybody know that this original parabola here, okay, has origin as the center, as the vertex. Okay, and the vertex over here is something that we don't know. Okay, we can find, but we don't know. We can find it by negative b over 2a, but we don't know. Okay, you can find it, but this one we know for sure that the vertex over here is 0, 0. The vertex right here is at the origin. It means what? It means that this equation here, after we manipulate, this equation also has origin as the vertex. Okay, and the same thing over here, this equation here has the vertex, has the same vertex as this one, because this one is come from this. Okay, this one will come from this. All right, so it means what? It means what? It means that because this is the vertex is at the origin, this is the vertex is at somewhere else. Okay, so what? So basically we can graph it, right? Okay, basically we can graph it. Right now we don't know what does it mean p. Okay, we just know the p is 1 over 6t. Okay, and we know the p over here is 1 over 8. But graphically, we don't know what p's mean on the graph. So we're gonna just go ahead and graph it. Okay, so we're gonna go ahead and graph it. So okay, so we're gonna graph this one. Okay, actually we just sketch it. We know that this is the one is opening up, right? Okay, and it's go through the origin. You go through the origin, so it's gonna be something like this. Okay, we just sketch it. Okay, I don't know exactly what point it's going through, so I'm just sketching. Okay, all right. But what happened here? What happened here? What happened here? The one right here, the graph for this one. Okay, this graph, this equation here, this parabola here doesn't have origin as the vertex. The vertex must be somewhere else. And where the vertex? Where the vertex? The vertex will be right here, the value right here, the number right here. The vertex will be 1 and 3. So the vertex will be this. So it will be 1 and 3. 1. It will be 1 and 3. So this is, I'm going to have 1 over here. 1, 2, 3 right here. So the vertex will be right here. So the parabola is going to be opening up like this. Okay, it's going to be opening up like that. Okay. Then what is the p-value graphically? The p-value, okay, the p-value over here is 1 over 16. It tell you what? It tell you that it tell you the distance between the origin, okay, between the vertex and a point inside parabola is 1 over 16. So the distance from here to here, okay, is 1 over 16. It's 1 over 16. Okay, Of course, this is just a sketch. You know, the increment is not good. It's not scale, so it's just a sketch. But we know that P is the distance from the vertex. Okay, P is the distance from the vertex to a point inside parabola, and that point we call the focus. So this point right here we call the focus. Okay, that point right there we call focus. Okay, and from the origin we going down by a p value. Okay, we going down by a p value. It means negative 16, right? It means negative 1/16, and we draw the horizontal line. Okay, we draw the horizontal line. This line right here we call directrix. Directrix. So the directrix over here is y equal negative 1/16. Okay. All right. So the focus right here will have the coordinate. What is the coordinate right here? So the focus F will have the coordinate is 0, 1/16. Okay, all right. Okay, and if I draw a horizontal line that cut the parabola at 2 points, the 2 point right here. Okay, it's 2 point right here. These 2 points here, they has a very special name. We call that lattice rectum. So this is called lattice rectum. I don't know why they call it rectum, but that is the name. Okay, so this is 2 lattice rectum. Okay, all right. And another good thing about this, another good thing is that if we pick a point on parabola, okay, let's pick a point on parabola. Let's see if I can use another color, but I don't have it. It look like, because this is green one, but I mean on the screen it look like black, but I think I'm gonna use red over here. If I pick a point, any point on parabola, okay, and I connect it to the focus, okay, and from that point I draw perpendicular to the x-axis, okay, then I know for sure that these 2 segments here are congruent. Any point, okay, for example, if I pick a point here, okay, I pick a point here, and I draw perpendicular to the x-axis, then I'm sure that this is perpendicular. This is congruent. Okay, and the ratio between these two segments here, okay, so I'm gonna name it. So this is F, right? So this is F right here. So I'm gonna name this is A and this is B. Okay, the ratio between these 2 segments here is always 1. It's always 1, and that ratio, okay, we call that eccentricity. Okay, we call it eccentricity. Okay, so everybody remember. So this point right here we call the focus. This is called directrix. Okay, the ratio between these 2 segments we call eccentricity. Okay, the point right here, these 2 points we call lattice rectum. Okay. Okay, so from this example here, I can deduce a general formula and general information for all parabola. For all parabola which y-axis is the symmetric axis. Okay, alright, so I can get the general formula for this. So the general formula will be general formula will be what? Will be x squared equal plus or minus 4py. Okay, plus or minus. Why I say minus? Because if it is minus, it's gonna be upside down. Okay, and with the focus will be what? Will be 0p, okay, or 0 negative p, so plus minus. Okay, the directrix, so this is focus. The directrix will be what? Will be y equal what? Y equal to plus minus p. Okay, plus minus p. If it is upside down, then it will be y equal to p. It's going to be open up, then y equal to minus p. Okay, and the eccentricity, I think I'm going to write the eccentricity. I'm going to spell that word. I forgot how to spell that word. Eccentricity. Let me get it over here. I just suddenly forgot how to spell that word. Okay, eccentricity. Okay, eccentricity. Okay, notated as E value is always equal 1. It's always equal 1 because the eccentricity is the ratio between FA and AB. Okay, everybody clear? So this is general formula for all parabola which y-axis is the symmetric axis. Okay, now let's go to this one. So right now the vertex is not at 0 anymore. It's not at the origin anymore. The vertex is on 1 and 3. Okay, P is the distance over here. P is the distance from the vertex to a point inside parabola. So P over here is also a distance from the vertex to a point inside parabola. So this point inside right here we also call focus. So P is from here to here. So P will be 1/8. Okay, P is from 1/8. Okay, and from the vertex, if we go down vertically by 1/8, we will also get a line, and that line is also called directrix. So the line will be y equal to what? Y equal to what? It's not y equal to 1/8 anymore, right? Because y equal to the distance from here to here, it go down by 1/8, right? It go down by 1/8. So you see the total is what? From here to here is 3, right? So over here will be 3 minus 1/8. Okay, so it will be from here to here. Alright, so we from here to here. Okay, 3 minus 1/8 will be, it give you 23/8. So y will be equal to 23/8. Okay. Then what is the coordinate of F? What is the coordinate of F? The coordinate of F will be a little bit different, right? The coordinate of F will be what? The coordinate of F will be x equal, the x component will be 1, right? And the y component will be what? The y component will be from here to here is 3. 3 plus 1/8. So 3 plus 1/8. Okay. So my focus will be 1, 25/8. Right? So be careful, because right now the vertex is different. You know, most of the instructor will show you the method of memorizing. But when I'm learning the conic curve, I don't think that we should memorize the formula. We have to understand it. That's much easier to deal with conic curve. Okay. You see, so far I just give you the general formula for the parabola, but I mean when you're dealing with the one which the vertex is not the origin, could be a little bit harder, a little bit different. Okay. Alright, so from here, okay, let's see what else I have. Okay, one more thing. I'm gonna talk about the lattice rectum. So we're gonna have we also have a lattice rectum right here. Okay, we don't know what is the coordinate for the lattice rectum, but I mean we can find it easily. Okay, and any point. Okay, any point. Let me see. Any point on. Any point on the curve. Okay. Okay, any point from and we connect that point to the focus. Okay. Let me see. God, I want to talk about eccentricity of the parabola also. Hold on, I just want to make sure that everything is okay. So any point from, I think I messed up right over here, because so any point from the focus, from any point between if you pick a point on parabola and you connect it to the focus and you draw perpendicular, because this is just a sketch, so it should be equal, but it's not, and I draw perpendicular to the, yeah, it should be, I'm sorry, it should be right here. I draw perpendicular to this, I'm sorry. So it should be equal, so right here. So B is right here, okay? Okay, because this is a sketch, so it means you see that it's not scale, so it's not equal. So this distance right here. Okay, so the FA equal to ABB is right here. I'm sorry, guys. See, I mean, because my picture is not scale, so it's not good. Okay, so if I pick a point right here and I connect it to the focus, and from that point I draw perpendicular to the directrix, okay, it should be equal. And you see that over here in my picture it's not equal because my picture is not perfect, you know, it's not scale, so it's not good. Okay, I mean it's supposed to be equal. And because it's supposed to be equal, so the eccentricity must be the same. It must be equal 1. I'm sorry. Okay. I'm sorry for this. So it should be all the way down here. So the B value right here is not here. It's all the way over here. Okay. Okay. Let's see. Alright. Good. Yeah, my picture is not good. That's why you know, that's why I thought that this is directrix, but this is directrix right here. So the distance between A and F is equal to the distance between A and B. AB is the segment that perpendicular to the directrix. It's not just it's perpendicular to the X, but it's also perpendicular to the directrix. And FA equal to ABB is from here to here. Okay, A from here to here. All right. It doesn't look like equal because my parabola is not scale. I just sketch it. Okay, the same thing over here. Same thing over here. All right. So from this example, okay, I can write a general formula. Okay, for any parabola, okay, for any parabola which vertex is not the origin, which the axis of symmetry is not the y-axis, but the axis of symmetry is also a vertical axis. It's vertical line, so it's right here. Okay, so my general formula will be x minus h squared equal plus minus 4p y minus k. Okay, and the vertex will be h and k. Will be h and k. Of course, the e is also 1. Okay, I'm not going to write the coordinate of the focus and the directrix because the vertex is changed already. Okay, the vertex is changed already. So every time you want to find the focus, the coordinate of the focus of such parabola or the directrix, you should go ahead and graph it. Or you try to use the information given in the question. Don't use the formula because the formula is, I mean, it's, you're gonna learn that by routine. You don't learn because if you learn the formula, it's not good. If you learn that way, it's like you learn math by routine. So you should learn it by the logic, by graphing. Okay, so in order to get the coordinate of the focus or the line, the directrix line, okay, you should graph it. Okay, then you locate the focus. After you locate the focus, then you know the equation of directrix. Okay, all right. Okay, so that is the case. I'm gonna just go ahead and box this. Okay, so that is a general formula when we're dealing with a vertical parabola. Okay, let's go to the example. Let's go to the example. Okay, let's do this one. How about this? X squared given x squared plus 4y equals 0. Right. So you see that we can recognize right away that this is the form. It'll be something like that, right? But at the original function, the original equation here is not. Okay, so in this question they ask you to find focus and directrix equation. It's very easy. Answer. Okay. So parabola is kind of hard. The conic curve is not easy, guys. I mean, you have to learn very carefully. You really understand it. Okay, don't learn it by formula. Okay, if you learn it by formula, I just need to change a little bit and you mess up right away. Okay. Alright, so because you recognize right away over here is in this form. It's in this form. So I'm gonna change a little bit. So I'm gonna bring it to x squared equal to negative 4y, and the general formula is negative 4py, right? Or positive 4py. So in this case, negative. So I know that I can write as negative 4 times 1y. So p in this case, what? P equal 1. P equal 1. Right? And we know right away this is upside down. Okay? Because it's negative. And because it's upside down, okay? Because it's upside down and the vertex or the origin. Okay, so you know the F will be somewhere right here. Okay, then the focus, the coordinate of the focus will be what? Will be 0, negative 1. Right, 0, negative 1. Because P is the distance from here to here. P is the distance from here to here. Okay. If P is the distance from the focus to the x-axis in this case, and F is under the axis, so it must be negative 1. Okay, so F must be the focus will be 0, negative 1. Okay, how about the line of directrix? Directrix must be up here, right? So the line of directrix is going to be y equal to 1, because this is negative 1 already, and the distance between focus and the origin to directrix must be equal. Okay, you remember the eccentricity is always 1, so must be equal. So that's why the line of directrix must be 1. Okay, so I'm 1 right here, y equal 1. Okay, very easy. All right. I can give you another example. So this is example 1. Example 2. Given y equal to 1 over 2x squared. find focus and directrix equation. Right. Answer. Okay. So we know the formula is x squared equal to negative 4py, right? So in front of the x squared, we shouldn't have any number. So first of all, we need to convert this. So y equal to 1 over 2x squared. I'm going to multiply both sides by 2. So my equation becomes x squared equal to 2y, right? But the general formula must have 4. Okay, so I'm going to change a little bit. So this is equal to 4 times 1 over 2y, right? And this is positive, so we know it's going to be opening up. Right? It's going to opening up, so it's going to open something like this. And the f must be somewhere right here. We know that this is p, so p is a half. So p is from here to here. Okay. Okay. Then from there we can get the point f right here must be 0 half, right? It will be 0 half, right? And directrix will be what? Directrix will be down here, right? It will be y equal negative half. Okay. So by look at the question, or by look at the information they give you, you know right away. You probably know right away it's opening up or opening down. Okay, it's opening up or opening down. You know right away. Okay. All right. Example 3. Let's see. Let's see. I can give you something. All right. How about this? Okay, how about this? I try to give you some question of writing equation of parabola. Let's see we have it or not. And we want to write the vertical one, because right now we do the vertical one. So let's try to find something vertical one. Okay, how about this? Okay. Right, equation of parabola, okay, which focus is 0, 2. Okay, with focus is 0, 2. Answer. Alright, so if you read the information, the focus is 0, 2, it means what? It means the focus F is on the y-axis, right? And if the focus is on the y-axis, this is above the y, it's above the x-axis. 0, 2 is above the x-axis, it's on the y-axis. It means your parabola must be opening up like this, because 0, 2 is right here. And if it is opening up, you know that you must use one of these formula. Okay, then your equation must be x squared equal to, because it's opening up, and because f is 0, 2, so it must be opening up. Okay, 0, 2 must be opening up. Okay, so let me see. It could be opening down. It could be opening down because it's gonna be like this. Okay. Yeah, but if it is like this, then the origin, the vertex is not 0 and 0 anymore. Okay, so in that case we don't count. Okay, we just because they asked you to write in the equation, so we just need to write 1. So either case work. Okay, so we're gonna write x squared equal to 4 py, and p is 2. P is 2 because 0f, this f right here, f is 0, 2, so p must be 2. Okay, so my equation become x squared equal to 4 times 2y, so give you 8y. Okay, so let me consider it could be opening down or not. Okay, because if it is opening down, think about that. If it is opening down, then the vertex is not at origin anymore. The vertex must be 0, 0, 0 and something y, right? Okay, 0 and something y. Okay, so it could be like this. So in that case, we don't have enough information. So the question is just asked you to write the equation for parabola when we have this information only. So if it is upside down, we don't have enough information to write. Okay, we don't have enough information to write. Just imagine. Let me get a scratch some paper right here, and I can show you really quick. Let me see. I can have some scrapping. Okay. So if it is, look at that. If it is opening down, right? So you're gonna have a 0, 2, 1, 2 right here, right? Okay. And so the parabola will be something like that, right? Okay. Okay, let me see. So in this case, let me see if we have enough information to write or not. So 0 and 2, that's the focus right here. Yeah, we don't know. You see that? If it is 0 and 2, we don't know the value from here to here. You know, we don't know the value from 2 to the vertex. Actually, they don't give you the vertex either. So we don't have enough information. Because it could be like this. You know, it could be like that. 0, 2 is from here to here. So we don't have enough information. So we cannot do it. Okay? Because it's just asked you to write the equation of parabola, so you should write the one that you can use information given. Okay? If you don't have enough information, of course you cannot write that, right? So you must have to use the information given in order to write the equation, the appropriate equation of parabola. Okay. All right. Let me see, I can give you another example. Example 4. This is a long lecture because there's so many example you guys need to be exposed to. The equation of parabola, okay, with OY as symmetric axis, okay, vertex is at origin, and this parabola is going through point M -4, 2. Okay. So how? So we know that OY is axis of symmetry, so it means it must be opening up or opening down, right? The vertex is at the origin. Vertex is at the origin. So and -4, 2, and going through point -4, 2, the coordinate of this point will tell you that the parabola is going up or going down. Okay, so -4, 2 is right here, 2, -4, and 2 right here, 1, 2 right here. So it must be opening up. It must be opening up. Okay, it cannot be opening down. It can't. The only way that goes through -4, 2 and opening down is like this. But if it is like this, then the vertex is not at the origin anymore. See that? Impossible. So it must be opening. And if it's opening up, we will have x squared equal to 4py. So our goal right now is to find p. And we know the point is -4, 2 going through, okay, by parabola. So we just plug them in. So we use -16p. So p equal to 4 divided by -16. So give you -1/4. Okay. So p equal to -1/4. Then I plug them back in, so I can have x squared equal to 4 times -1/4 y. I think I plugged them wrong. So the x should be -4. So see, I plugged them wrong. So the x should be -4. I'm sorry. So give you 16 right here, and the y is 2. So give you 8. So it should be 16/8. So it should be 2. So p is 2, and if p is 2, so you're gonna plug right here. So you're gonna have x squared equal to 8y. Okay, so the final parabola equation will be x squared equal to 8y. Okay, so that is how you're gonna write equation of parabola. And so far you see we have not done any example for the case when we have vertex is another point other than origin. Okay, so let's see, I can find some case like this. Okay, let's see. So we have something with x squared, right? Let's see. There's so many examples. Let me see. I couldn't find any over here. That's strange. Just be patient with me, okay? I mean, I'm trying to find the problem that the parabola has vertex that different from the origin. So let me see if I can find this over here or not. Oh, okay. Let's see. That's a long lecture, right? Okay. How about something like this? Example 5. Okay. Write equation of parabola okay that opens downward, okay, which vertex is -2, -4, okay, and go through points and go through point so 2, -4 is right over here. So 2, 1, 2, 3, -4, -4 right here. So this is the vertex. So something like this. And go through point what point? Go through point 0, 0, -6. Alright. Okay. So you see, every time you deal, I'm dealing with connect curve like I always graphing. Okay, let's see if we can do this solution. So we know that it's opening down. Okay, so if it is opening up or down, and the vertex is not the origin, so we have to use this. Okay, and we know that the vertex is 2 and -4. So let's write out the formula first. So we're gonna have x minus h squared minus 4p y minus k, right? So h and k, well, h and k is 2, negative 4, so we have x minus 2 squared minus 4p, y plus 4. Okay. So right now what? Right now we just need to find a p value. And let's say what? Let's say that it's going through 0, negative 6. So just plug them in. So it will be negative 2 squared, equal negative 4p, y is negative 6 plus 4. So give you negative 2 squared is 4, so negative 4p times negative 2. So it's 4 equal 8p. Right? So p equal to 1 over 2. Right? Then my equation will be what? Will be x minus 2 square minus 4 times 1 over 2 times y plus 4. Right? Then it become negative 2 times y plus 4. So that will be your equation of parabola. Whose vertex? Which vertex? 2, negative 4. Okay, very easy. Okay. Excuse me. Alright. I tried to find something more interesting, you know, another example, something challenging, so that you can feel interested in the conic curve. But I couldn't find any so far. I can make it up, but let me see I can find something at this moment or not. Let me see. Okay.